Good afternoon, everyone. My name is Rami Radi. I'm a product manager and solutions architect at AMI, and I'm responsible for a product called Data Center Manager. It's a software solution designed to allow data center administrators and operators to more efficiently manage their servers and IT devices from a utilization perspective, health, infrastructure, and firmware management, and carbon emissions management as well. So I wanted to give you a quick background about our company, since AMI is not a typical name that you hear in the data center management space. AMI has been around since the 80s, and back then has focused primarily on PC BIOS. So you might remember the American Megatrends logo when you booted up your home PC for the first time. And since then, the company has obviously evolved and has grown, and is now the #1 vendor for server firmware. And our main three products are shown over here. For server BIOS, we have Aptio, and for server BMC, which is called Baseboard Management Controller, we have Megarack, and for security, we have Tectagon. But as we continue to grow over the years, we've focused more on higher level software that we develop for OEMs and ODMs, as well as data centers, enterprises, and CSPs, and even hyperscalers. And that's part of our premium software services, which DCM is a part of. So DCM is a software that essentially communicates with the dedicated management controllers of servers and other IT devices, and pulls in the telemetry that they expose, which communicates with an embedded controller called the baseboard management controller. And it collects, aggregates, and analyzes that data without the need for any software agents to be deployed on those servers or devices, and exposes that to the end user through different use cases through a web console. And in this case, the end user is an administrator or an operator that is responsible for the maintenance and upkeep of the data center, but not necessarily the persona that is running workloads on the devices themselves. So this is an on-prem solution, so all of the data that is collected is stored locally. And because it is an out-of-band solution, this is what we call out-of-band management. Because it's an out-of-band solution, it is easy to be deployed, it's secure, and has no impact on performance or latency. And again, because it's on-prem, no data is exposed to the end user, to the outside world. So one thing that's worth mentioning here is that from a server perspective, we're vendor agnostic. We've supported generations of Intel platforms. We've added support for newer AMD platforms, and with our latest release, we've added support for ARM-based servers, including Ampere and NVIDIA Grace CPUs as well. And as I'll talk a little bit more in depth in the next slide, we support a lot of vendors, so we're really vendor agnostic. And the whole idea is to give you a single pane of glass solution that gives you an IT-centric way of managing your data center. Diving a little bit deeper on how DCM works, it uses essentially industry standard protocols like IPMI and Redfish to communicate with servers, and it collects that telemetry through the BMC, the baseboard management controller, whether it's using our firmware or even other firmware. Like, for example, servers from HP that use ILO or iDRAC from Dell. Regardless of the server model or vendor or architecture, we are able to communicate with it. And for other types of devices like power, storage, networking, and cooling devices, we use mostly SNMP, but there's also a move towards Redfish for those types of devices as well. So all that data gets collected by DCM, and by default, that includes power, utilization, health, inventory, information. But for the devices that expose additional type of telemetry, for example, some CDUs expose humidity sensors and other types of stuff, DCM also collects those too. So one thing that I want to really emphasize here is that based on all what I shared, DCM is not a DSIM solution. DSIM solutions typically, as you probably know, focus on the facility side of data center management. They focus on things like asset management, lifecycle management, crack unit management, security, all that kind of stuff. We focus on what's inside the rack, the servers, the IT devices, like I mentioned. We're not a server management solution in the typical sense either. Those are typically single vendor focused and do not include features like batch firmware updating that is vendor agnostic, or focus on things like sustainability metrics either. And we're not a really cluster management or workload management solution. Those are much more focused on the application layer themselves and how they operate and how they interact with the resources of a certain compute node. Right? So we're really a unique solution that's in the middle of all three, and we complement all of these different solutions. And we work with a lot of end customers that deploy these solutions and deploy DCM as well if they care about that additional layer of granularity that DCM provides. So, and all of the use cases that DCM provides translates into CapEx and OpEx savings. So whether it's being able to use DCM to eliminate the need for smart PDUs since we're communicating directly with those devices, or not needing the additional sensors that you may deploy around the data centers, again, because you're using the devices as thermal monitors themselves, or being able to extend the lifespan of your devices because you're able to more proactively manage their health and reduce the need to refresh the hardware. Or more OpEx-related savings, including being able to reduce your overcooling costs. Most data centers overcool their data centers just to be safe. There's really no need for that. And DCM, as I'll show in a little bit, can help you identify those cases and help you safely increase the set point temperature, which could save a lot in terms of power consumption and energy consumption. Same thing with firmware management. Firmware management is something that AMI is close to AMI's bread and butter, as we say. So streamlining that and reducing the downtime caused due to firmware updating and management can be massive in terms of the cost savings that it provides. So all these use cases combined can add up to millions of dollars worth of savings for even a small or medium-sized data center with around 5,000 devices. If you're interested to learn a little bit more about these kinds of savings, please visit us at our booth and we can talk a little bit more about that. So for the rest of the conversation, I wanted to talk about some of the more specific data center and AI infrastructure management challenges that DCM helps address. So number one, we talked about this a little bit, which is the need to be able to be really vendor agnostic, because in AI infrastructures, you have really dense racks with heterogeneous types of devices, from servers from different vendors to other components like PDUs and power shelves and cooling units. There needs to be a solution that can manage all of those devices seamlessly from a single pane of glass, and that's one thing that DCM strives to accomplish. We support almost all of the manufacturers here from a power, cooling and networking and storage device perspective. And we continuously work and partner with a lot of those vendors to not just reactively support their models when they come out, but more proactively support them before they come out. Second thing is being able to aggregate all the data that you collect from an AI infrastructure on all the different levels. So while DCM collects that information or that telemetry on a node level, it's able to aggregate that not just on the rack level, but on the row level, room level, and even on the data center level. So you can really get a very granular view, but also a holistic view as well. And not only can you consume that data from the web console, which we spoke about previously, but you can also consume the DCM's capabilities programmatically as well. So we support now Apache Kafka data streaming. We have a vast set of RESTful APIs, as well as iframe integration. And those types of integrations allow us to work and partner with server vendors, DCM vendors, and allows us to work with customers that have their own homegrown solutions and make sure that they can consume DCM's more advanced capabilities. Next is, again, talking about firmware management. in AI infrastructure specifically, servers and devices are bought usually in a staggered way, and with each purchase, they come with different firmware versions, even for devices of the same model. And that could impact security, reliability, performance, and there's no easy way to see that across, again, a very dense environment with heterogeneous types of devices as well. So not only does DCM give you a single way to see all the firmware versions for all the subcomponents on a compute node, but you're able to identify if there are any outliers. Like in this graph over here, I'm seeing for a certain server model, most of my servers of that model are running a significantly older firmware version. So with just one click, you can identify that and take action accordingly. And for servers that do support Redfish-based firmware updating, you can do that in batches and schedule that to reduce downtime so that you can ensure that they're all running the same firmware version. Next is being able to utilize your resources more efficiently. So not only does DCM allow you to identify, for example, servers that are underutilized, and that happens quite a bit in the AI world as well. So all of the processing is happening on the GPUs. The servers are left more idle, doing nothing. So it allows you to identify those cases where you can, go with lesser hardware specs, for example, or move to newer, more efficient platforms, for example. And from a GPU management perspective, we've added capabilities to monitor and manage NVIDIA data center GPUs, as I mentioned. And with a graph like this, you can easily identify that the workloads running on the 16 GPUs on this server are highly unoptimized. They're spiking and scaling in a really weird way. So again, this is a very quick identifier that you might want to take a better look at how you're distributing your workload on this compute node, and maybe that's an issue on the entire rack as well. You can also identify things like power spikes and irregularities that could be caused due to hardware malfunctions or issues. So again, DCM very quickly can help you identify how those spikes are looking over time, and with double clicking into that, you can identify what's causing that. And lastly, again, related to what we talked about before, with CPUs running less of the workloads and more of them running on accelerators, whether they're GPUs or otherwise, there's more room to save on energy and power costs on the CPUs. So one of the strengths of DCM is being able to perform power policies or do power capping on a server or on the CPU level, so without impacting performance. So DCM allows you to find that sweet spot where, in this case, you're able to save around 15% of energy consumed on that server without impacting performance. And if you scale those savings on an entire cluster, that could have massive effects. Okay. Now, another very important problem, and I think there was a research conducted by Meta in 2024 showing that for a 50-plus day pre-training run of Llama 3, maybe 70% of all the interruptions happened due to unexpected hardware failures. So DCM is able to identify the components that are failing and allows you to proactively take action accordingly so that before they become catastrophic. And we can identify what we call failure indicators, even on the other components, not just the GPUs, but for things like memory, you're able to identify which memory parts are actually failing more than others. And that could help you with the RMA process. And some of our customers have worked with memory vendors and have used this kind of graphing to identify parts that have had manufacturing issues more than others, surprisingly. Of course, you can't talk about AI without talking about liquid cooling. So with all the vendors coming out now focusing on the hardware side of liquid cooling, there's a very little focus on the software management side of that. And again, DCM is really vendor agnostic. We work with a lot of the liquid cooling vendors to capture all that extra type of telemetry, whether it's flow rate, pump rate, reservoir levels, humidity sensors, leak detection, and that allows you to, again, take preemptive action and shut down the systems without before they become catastrophic and cause massive failures. And then with our ability to show a color-coded front view of the racks, you can identify, in this case, if one of the nodes is having health issues more than the rest. In this case, you can double-click on that and find that there's, for example, a leak with the tubes coming in out of that CDU specific to this compute node, right? And related to that is general cooling analysis. So you can use DCM. Again, we're using each device as a thermal sensor. So you're able to identify very quickly if you're unnecessarily overcooling your rooms. We find this happening all the time. And the amount of energy savings that you can make by safely increasing the set point temperature just a few degrees is phenomenal. And again, with this same kind of graph, you can identify those hotspots that we talked about. In this case, most of our servers are running cold, which indicates that we're overcooling, but there's one or two servers that are running really hot. And in this case, it was related to that leak that was happening from the CDU. Lastly, all this has to be managed while taking into consideration sustainability, right? With all the regulations coming up, both in Europe and in the US and all over the world right now. So what DCM allows you to do, since we're already collecting real-time power from the devices directly, it can show you carbon emissions on a device level and allows you to set thresholds on a data center level or on a cluster level, and allows you to, sends you alerts as you start to approach those limits, so you can again take action accordingly. And this graph over here shows you both annual, monthly, projected, and actual carbon emissions. That allows you to again make decisions, whether it's by doing things like performing power capping, which is a little bit of an extreme measure, but still a possibility, or have some server procurement decision making. Right? Okay. So with that, I just wanted to say thank you for listening, and this was just a very quick snapshot of some of DCM's capabilities. I'd like to invite you to come over to our booth for a more in-depth demo. Please talk to us. I know that this is a slightly different space that we're coming into this conference with, but we feel it's really important. There's a lot of focus that has been happening on the facility side, but with AI specifically, the need to focus on IT and server management is essential, especially with the GPUs and their failure rates. There's no escaping this. So we'd love to talk to you a little bit more, and we have a lot of t-shirts that we'd love to give you if you're interested and would like to see a more in-depth demo. All right, that's it. Thank you very much, everyone.